Hello, class. Confidence intervals. Capturing the unknown. Suppose we wanted to find the percent of all Fairview High School students who think backpacks should be allowed in the classrooms. So we go out and we do a sample. Not the whole school, just a sample. We don't have time to get the entire school. Not everybody's here. Anyhow, we want the percent of all Fairview students, but we are stuck with just a sample of Fairview High School students. And we're stuck with the percent of them that answered yes, that they think backpacks should be allowed. Does our sample ever equal our population proportion? Generally, no. It's never going to be right on. So is it a waste of time to sample then? No, it's not, because we can then create an interval and go from being 0% confident to being 95% confident that we have at least contained P. You see, we're never going to nail the population proportion exactly on the bullseye, but we certainly can use our sample to create an interval and be very confident we've contained it. How does that work? Here's a visual. Let's say that our population proportion is right down the middle of the normal curve, which it's where it will be on the sampling distribution, and it's the green line. Well, if we take a sample, our first sample misses, but our interval contains the population proportion. Let's say we did it again. We get a different sample. It missed again, but our interval contained it, as you can see. Our third sample, interval contained. Now, it's possible we get an unusual sample like this one, and our interval misses, and the interval didn't do its job, but that's going to happen rarely. See the area small out here? You're normally going to get a sample within this area, which your interval then will contain, kind of like the last one. Okay, so we actually did this question a couple years ago. We got 69 students to answer this question. We tried to get them randomly. 59 of the students said yes, backpacks should be allowed in the classroom. From there, we can calculate our p-hat. You guys know what a p-hat is, of course. It is the sample proportion. 59 over 69, 85.5% of students think that they should have a backpack in the classroom. Before we make this confidence interval, we need to make sure our conditions are met. Did we get a random sample? Well, we tried, but we basically just went to a few classrooms that were available. So I would put a question mark next to random sample. 10% condition, we might be a little over 10% of the entire school, so we'll question that. But our sample was large enough, so we can at least check our third condition. We want to multiply n times p hat and n times q hat, and they're both above 10. This one's barely above 10, but it's at least 10 or more. So what do we do with our p hat? How do we make a confidence interval? Here's what we do. We first need to calculate the margin of error. The margin of error is the z-score from the confidence level times your standard error. We know how to calculate standard error at this point. We're going to use p hat times q hat over n square rooted. Now, how do we find the z-score here of the confidence level? Well, we have a little table here. If we choose a 90% confidence interval, we're going to choose that z-score, 95%, 99%. These three are the most common levels of confidence. That's why we included them in a table. So now you can just use the table to put in your z-score up here. The confidence interval then, the last step is to take your p-hat plus and minus your margin of error. The margin of error is added and subtracted. This forms an interval, and this allows us to be however confident we've chosen here that we've contained the population proportion. Let's see that in a little more detail. So our p-hat, 86% of students said that we should be allowed to have backpacks in the classroom. But that number is not going to be exactly right for the population, so we're going to give ourselves a little error left and right. So we calculate our margin of error. Our z-score is going to be 1.96. I get that from the table. using 95% confidence level. I chose to be 95% confident. I will give you that for the problem. You can see how the 0.042 was calculated from the standard error. And then that gives us a standard error of 0.042, and that goes up there. Multiply 1.96 times 0.042, and you get 0.082. That's our margin of error. So we think we could be off by around 8%. That's what that means. Add and subtract that to your p hat, as you see being done right here. And there is our confidence interval. What do these two numbers mean? 77% to 94%. What does that mean? Let's backtrack to our interpretation. This means that we are 95% confident that between 77% and 94% of all FHS students think backpacks should be allowed in the classrooms. So here's what we did in a nutshell. We said we'd like to know what percent would say yes to this in our entire school. We're not able to get a census of our school or the country or the city, so we rely on a sample. We took our sample, we followed the rules, and we made an interval. And this interval now allows us to be pretty confident, 95%, based on the sampling distribution. We're 95% confident that we do know what the entire school would answer if we would ask the entire school. We think it's between 77 and 94%. And that, my friends, is a confidence interval. Good luck.